Now, let us study block in the periodic table in details. So, in S block, it is occupied by elements with a half-filled or completely filled outermost S orbital, meaning that in order to identify whether that element is located in S block ataupun tidak, you can see from its electronic configuration. Let's say we have lithium. So, lithium with 3 electrons, so the electronic configuration will be 1s2, 2s1. So, in order to know whether lithium is located in S block ataupun tidak, you can see at the end of the electronic configuration, which is at the valence shell. So, if the electronic configuration stops at S block, meaning that this lithium is located in the S block. So, this is the key point on how you can find the block of your element from the electronic configuration. Okay, that is, you may refer to the end of their electronic configuration. If it is stopped at P, meaning that it is located in the P block. So in the case of lithium here, its electronic configuration stops at S block, meaning that lithium is located in the S block. Group 1 and Group 2 are located in the S block. So for Group 1, they are metals excluding hydrogen. They are also known as alkali metals and their valence configuration will be NS1. For example, we have sodium. So this is the electronic configuration of the sodium. So from this electronic configuration, how is that possible for you to find the period, group and block for the sodium? So the answer is, or the hint is, you have to look at its electron configuration and focus at the end of the configuration. Okay, fokus pada configuration yang paling hujung tersebut and find the highest principal quantum number. Okay, cari highest principal quantum number in that electronic configuration. So of course the answer will be this one. Okay, in this highest principal quantum number, which is n equals to 3, kita ada blok apa? Kita hanya ada blok S sahaja. Okay, so the highest principal quantum number yang ada blok yang ada number of electron inilah yang kita panggil sebagai valence shell ataupun valence orbital. Okay, so in this valence shell, apa yang you boleh identify adalah this is n. N itu apa? Principal quantum number. So this n juga merujuk kepada period. Okay, so the S here refers to the block, of course. And the value of 1 on top of here, ini merujuk kepada valence electron. Okay, so from the valence configuration di sini, okay, in the valence shell, you will be able to find the period, the block, and also the number of valence electron. So by knowing the number of valence electron di sini, you can also find its group. Sebab untuk S block, number of valence electron bersamaan dengan the group itself. So kalau you ada 1 valence electron, bermaksud this element is located in group 1. So that's the way to find the period, group and block untuk specific element. And for group 2, it is also metals. Okay, and it is also known as alkaline earth metals with the valence configuration NS2. So for example, we have calcium over here. Can you identify which one is the valence shell for calcium? So kita guna hint yang tadi. Find the highest principal quantum number. Okay, so the highest principal quantum number will be 4. Okay, so 4 ini akan merujuk kepada outer shell ataupun valence shell. So in this valence shell, we do have 4. 4 ini merujuk kepada period. So the S here refers to the block and 2 over here refers to the valence electron. So since calcium has 2 valence electron, meaning that it is located in group 2. Kenapa? Sebab untuk S block element, number of valence electron equals to the group itself. Kalau valence electron adalah 2, bermaksud this element is located in group 2. So, for group 1 and group 2, in order to find the valence configuration, again you have to look at the end of the electronic configuration, find the highest principal quantum number, and that should be called as valence orbital or valence shell. So by knowing the valence shell, later on you can find the period, the block, and also the valence electron. And by knowing the valence electron, this will help you to identify the group as well. Elements that are located in the p block will have electrons in the outermost p orbital. So you may refer from their valence configuration or valence shell. So in the valence shell, di penghujung of the valence shell itu akan ended dengan p configuration, menunjukkan bahawa that element is located in the p block. So metals, metalloids and non-metals, they are located in the p block. So group 13 until group 18 adalah the example of the elements that located in the p block. And as you can see from the valence configuration over here, so ini apa? Ini adalah valence configuration. So from the valence configuration, you can see that we will end the valence configuration writing here with P. Okay, so untuk group 13, 14 until 18, kita akan stop valence configuration dengan P di sini. So ini menunjukkan bahawa these elements from group 13 until 18 is located in the P block. Dalam valence configuration, you have to add electrons pada S dan juga P orbital in order to get the total valence electron. And especially for the p block, in order to get the number of group from the valence electron, you have to add with 10. Let's take group 15 as example. The valence configuration is Ns2 Np3, menunjukkan jumlah valence electron adalah 2 tambah 3, which is 5. So to get the group for this p block element, you have to add 10 kepada valence electron tersebut, then you will get group 15. So let's take example for aluminium. So this is the electronic configuration of the aluminium. So from this full electronic configuration, can you identify the valence electron for aluminium? Okay, by applying the concept we have learned in S block just now, again, in order to find the valence configuration, you need to identify the highest principal quantum number. So definitely in this aluminium, the highest principal quantum number refers to 3. So the number of orbital ataupun block yang berada pada n equals to 3 ini ada 2, iaitu 3s and 3p. So any orbital that lie in the same principal quantum number, kita akan klasifikasikan sebagai valence shell. So blok yang berada dalam principal quantum number yang paling tinggi ini akan kita kategoriskan sebagai valence shell. So these are the valence configuration or valence shell untuk aluminium. You can also find the period, group, block, and also the number of valence electron. Okay, now, so how to find all those 4 yang I mentioned tadi? So firstly, you can see from this number 3. So this 3 refers to, of course, the period. Okay, period of the valence shell. And then for the block, you have to refer to the end of the electronic configuration, at the end of the valence configuration. At this end, we have p orbital, meaning that this element is located in p block. And then for the valence electron, untuk p block, in order to get the valence electron, you have to add, you kena tambah valence electron pada Ns dan juga pada Np. So in this case, we have 2 electrons on the s orbital and 1 electron in the p orbital. So the total of these 2 is 2 tambah 1 equals to 3 electrons. So bermaksud aluminium will have 3 valence electron. And how about the group? How to find the group for p block? In order to find the group for p block, we have to add with 10. Okay, so 3 valence electron tambah dengan 10, maka you akan dapat kumpulan 13. Okay, next example is bromine 35. So this will be the electronic configuration for the bromine. And here will be the valence configuration.
Again, you have to repeat the same process by looking at this full electronic configuration. Find the highest principal quantum number to determine the valence configuration. So in this case, we find out that we have n equals to 4, which belongs to orbital 4s and 4p. So meaning that these two orbitals are located in valence shell. So, principal quantum number atau orbital yang paling tinggi adalah orbital 4, n equals to 4. Maka di situlah kita akan merujuk kepada valence configuration.
So, at the end of this valence configuration, it stop until P, menunjukkan this element is located in the P block. And 4 here merujuk kepada period of this element. And for the valence electron, you must add between 2 and 5 di sini. So, bila katakan 2 tambah 5, kita akan ada sebanyak 7 valence electron. Okay, so 7 ini adalah valence electron. And to know the group of this element which is bromine, so from the valence electron, awak kena tambah dengan 10. So, awak akan dapat 17. So, 17 is the group for bromine. And this is consistent with what you can see in the periodic table. So, untuk P block, please remember, in order to find the group, you have to add the valence electron dengan 10. And for the P block as well, in order to find the valence configuration here, you must consider all orbitals that are in the same principal quantum number. Transition elements are located in the D block, and their D orbitals can be filled with partially filled to completely filled D orbitals. If you still remember, like what we have did in chapter 2, in order to fill electrons into transition metals, you will completely fill the 4s orbital first, then the 3D. Okay, so you can see that in this 3D, for example, okay, I did fill with 1 electron. So this shows the partially filled configuration. And also in this 3D, we can fill up to 10 electrons in the 3D, depending on how many electrons in that element. The number of the electrons in this D orbital could be from partially filled, which is 1 just now, until completely filled orbitals, okay, which is 10. So this is referring to their elements juga. Okay, dia proton number. So that proton number akan determine lah, okay, berapa banyak jumlah elektron yang akan diisi di sini. Okay, sebab according to the electronic configuration of the transition metal, kita for sure akan isi penuh untuk 4s dahulu, and then baru kita isi untuk 3D. And the valence configuration for transition metals will be from n-1 D1 NS2 until n-1 D10 NS2. Kenapa macam ini? Sebab dalam transition metals, the number of valence electron equals to the group number. So in this case, kita ada D has 1 electron, S has 2 electrons. So the total of these two will be 3. So 3 ini akan merujuk kepada apa? Valence electron dan juga group of the transition metals. And then this 10 plus dengan 2, you akan dapat total adalah 12. So this 12 belongs to valence electron and also the group of the transition metals. So this is consistent with what we have in the periodic table, iaitu in the region of the transition metals, the groups are from group 3 until group 12. And why it is n-1d and ns for the valence configuration? So for the valence configuration, let's say this n is 4th principal quantum number. Let's say this n is n4. So for ns2, the configuration will be 4s2. And then to get the value of n-1d, maksudnya bila n kita dah 4, so n-1 maksudnya 3 lah. Okay, so bermaksud untuk d orbital tu dia punya configuration adalah 3d1. Okay, why we can get this configuration? Sebab semasa awak isi elektron, kita akan isi pada 4s dahulu. So 4s akan dipenuhi dahulu. Then later the 3D. So in order to get the number of valence electron and also group for transition metal, we have to consider this valence configuration. So what is valence configuration untuk D block? Ingat, N-1D and NS. Okay, so untuk kes yang ini, it is 3D1 4S2. Now, let's take vanadium as the example. So by writing its electronic configuration, you will fill the electron according to increasing energy level. And of course, kita akan fill dengan 4S dahulu, dan baru you penuhkan untuk 3D. And please remember, after you have complete writing this in this sequence, please make sure you change the position between the 4S and 3D. Kenapa? Once 4S ini dah terisi dengan elektron, its energy level akan gets higher, okay, compared to the 3D. So you have to rearrange the way you tulis electron configuration. So by doing that, you will get this electron configuration, okay, yang final. Okay, now from this electronic configuration, can you identify which is the valence shell or valence configuration for the vanadium? Okay, now, so by applying the same concept we have learned in S and P block, you have to find for the highest principal quantum number. So by doing that, you akan nampak inilah the highest principal quantum number kita, which is N4. Tapi adakah this is the valence configuration for vanadium? Okay, so jangan cepat cari jawapan. Kita tengok jiran di belakang of the 4S, jiran sebelum the 4S tu. So here we have 3D orbitals just before the 4S. So by having D orbital before the 4S, you tak boleh ambil 4S ini semata-mata sebagai valence shell. Okay, sebab ada D di belakang. Okay, kalau you compare dengan case S orbital tadi, okay, walaupun di hujung ni kita ada S orbital, okay, orbital sebelum dia tak ada D. So that's why kita hanya akan choose S orbital ini sahaja sebagai valence shell untuk S block. Tapi when it comes to D block, you have to double check the orbital before the 4S. So kalau orbital sebelum 4S ini kita ada D orbital and the principal quantum number here is less 1 the principal quantum number in S di sini, maka in order to get the valence configuration, you have to take both of these orbitals sebagai valence shell. Okay, now, so in this valence shell, apa dia punya principal quantum number yang paling tinggi? It is N4. Okay, so bila N4, maksudnya ini adalah period. Okay, so let's recall pada permulaan electron configuration awak tadi. So in the first electronic configuration, you fill the 4S. You write the 4S first, then the 3D. Okay, so semasa permulaan awak tulis electron configuration, awak akan isi S dahulu, baru awak isi dengan 3D. So bermaksud D di belakang. Okay, so bila D di belakang, bermaksud kita akan ambil D ini sebagai block. Okay, walaupun period kita ambil yang ini, tapi block kita ambil yang ini. Okay, so ini adalah untuk D block. So, to get the valence electron for this element, maka again, what you have to consider, you have to consider both electron on D and S orbital. So, in this case, the number of valence electron here will be 3 plus 2 equals to 5. So, 5 will be the valence electron of vanadium. So from the valence electron, you can simply terus cari dia punya group. Kerana untuk D block element, number of valence electron also refers to the group of the elements. So inilah yang membezakan di antara 5 valence electron in D block and 5 valence electron di dalam P block. So definitely, P block element yang having 5 valence electron dan D block elemen yang having the same 5 valence electron akan berbeza in terms of their group. Okay, dengan cara mana? Dalam transition metal D block, number of valence electron akan reflect dia punya group number. Tetapi dalam P block, walaupun dia ada 5 valence electron, to get the group, you have to add dengan 10. So, itu bezanya di antara valence electron yang sama untuk P dan D block, tetapi berbeza in terms of their group. Next example will be zinc. So, zinc pun sama juga in this electron configuration. You akan fill the 4s first and then the 3d. And not to forget, you have to switch the position between these two, becoming like this. And for here afterwards, find the valence shell or valence configuration. So, apa yang awak kena buat? Cari orbital yang paling tinggi. Principal quantum number yang paling tinggi. So, definitely we have 4s dekat sini. Okay, dan jangan terus ambil 4s. Check dahulu jiran sebelum dia. Oh, ada 3d. So, maksudnya, you have to consider this both. Okay, sebagai valence configuration. And please make sure this D, dia punya principal quantum number must be less 1 than this S. So, kalau yang ni 4S, here must be the 3D. So, from this valence configuration, again, you can find the period. So, which one is the period? This is the period. And how about the block?
Block you should find from the 3D.
Okay, so this will be the block. And for the valence electron, you have to add 10 and 2. So, the total of the valence electron will be 12. Valence electron 12. Group pun adalah group 12. Elements in the periodic table also can be classified as metal, nonmetals, and metalloids. So these are the elements of metals in the periodic table, except the hydrogen. Metalloids are the elements that have both properties of metal and nonmetal. So here are the region of the metalloids, okay, the region that separates between metal and nonmetal in the periodic table. Hydrogen and the elements in the right of the periodic table here are nonmetals. So across the period from left to the right, elements gradually lose their metallic character and gain nonmetallic character. So these are metals and these are nonmetals. So moving from left to the right of the period, the metallic character will be decreases and non-metallic character will be increases. Now, let's do this example. Classify the following elements into its appropriate group, period, block, and valence configuration. So, we have P, Q, R, S, T, U elements here with their respective electronic configuration. So, you have to find their group, period, block, and valence configuration. So, you may pause for a while, and by applying all the concept and hints that you have learned in the previous slides, try to figure out the answer for this question and you may check with the answer on the next slide. Cuba buat dulu, okay? I know you can do it.
Thank you for watching, everyone. I hope this video could help to enhance your understanding in chemistry. Have fun in your learning and remember, chemistry is easy and fun.